Hello and welcome back to another episode of Maths with Sohn. Today we are going to be simplifying and doing operations with complex numbers. So let's get into it. So a complex number is something where you have an imaginary number and normally like a real part as well, like 5 and 2i. And doing some operations with it, we are going to have to know how to add, multiply, and subtract these. So if you're adding a complex number with another complex number, like so, all you have to do is treat the I exactly like it is an x. So if we have 5 and 6 and we are adding them together, those are like terms, we get 11. And if we have 2i and negative 3i, if we add those together, we get negative 1i. And that's it, ladies and gentlemen. It is that simple. Adding imaginary numbers is one of the easiest things you could ever have to do. And subtracting is not much harder either. So if I had something like 4, let's go plus 3i, minus, let's go with a 6 minus 4i. If you're subtracting, then what I would recommend is that you subtract both of these, but I recommend that you distribute the negative. And when you distribute the negative, just change it to a plus sign and end up making it a negative 6 and a positive 4i. And if we combine like terms from this stage, then you're going to only have to do what we just did on the previous problem, where you're just combining 4 and negative 6, which makes negative 2. And you're combining 3 and 4i, which makes 7i. And that is all she wrote. You don't need to put it in parentheses. And that's the answer. I do want to stress that it's supposed to be an a plus bi form, so technically the I, the imaginary term, should come last. It should not be first. That's a technicality. Does it affect the actual problem? No, but that's just the way it should be written. All right, so we've added, we have subtracted. We still have to multiply imaginary numbers, and that's one of the harder things to do. So one thing to recognize is that I is the square root of negative 1. Okay? So I is the square root of negative 1, which means that if I were to square it, I squared would equal the square root of negative 1 squared. If you were to square this, the square root would go away and you just get left with negative 1. And that's a very important feature because that is by far the most important thing, but it actually will follow a cycle. I squared may be equal to negative 1, but if we have I to the third, that would be the square root of negative 1 times an I squared, because we would have I times I squared. Essentially, that is I to the third, which makes negative I. And then I to the fourth would actually be an I squared times an I squared, which is negative 1 times negative 1, or positive 1. And then it's going to follow a cycle. After I to the fourth, you end up with I to the fifth, and I to the fifth would just equal 1 times I, because it'd be I to the fourth times another I, which just means it's I. And then it just follows a cycle and a cycle and a cycle. But all of that, normally you just need I squared is equal to negative 1. If you only memorize one of those, I squared is equal to negative 1. I squared equals negative 1. So let's do some operations with that. So let's say we have 3i times 4i minus 7. You distribute just like you've been doing forever. Distribute, we end up with 12i squared minus 21i. And if you end up with an I squared ever with imaginary numbers, you turn it into negative 1. And then that would make this negative 12 minus 21i, because negative 1 times 12, because we replace this I squared with a negative 1, makes negative 12. And that is our final answer. So with multiplying imaginary numbers, you could end up with a scenario where you have to distribute. You could end up with an easier scenario like 2i times 3i times I, something simple like that. And in this case, I would recommend doing it separately. I would do 2i times 3i first and get 6i squared. times I. And what is I squared? If you see an I squared, replace it with a negative 1. Don't end up multiplying them and getting I to the third, because then you have to memorize what we did up here. 6 times negative 1 would be negative 6, and then the I is just there. Ta-da! The third thing with multiplication that we sometimes have to do is if it is two complex numbers, so we have something like 2 plus 3i and 3 minus 4i multiplying together. And here you have to FOIL. You got to do the double distribution, the first, outer, inner, last, where you have to multiply the 2 times both terms. 2 times 3 is 6. 2 times negative 4i is negative 8i. And then the 3i times both. 3i times 3 makes 9i. And 3i times negative 4 is negative 12i squared. Combine any like terms that you may have, which we have a like term here in the middle. Negative 8 and positive 9 makes a positive 1i. The 1 is not necessary. You can just write I. Then you also have negative 12 times an I squared, and if you replace that with a negative 1, it's going to change the sign of this negative 12 to a positive 12. And if we were to take that positive 12 that it really is and combine with the 6, because these are both now like terms, if you combined this positive 12 and that 6, you end up with 18 plus 1i. And that is our final answer. So foiling takes a little bit longer, but it's still the same process. You just multiply everything out, combine like terms, turn any I squareds into negative 1. So we've added, we have subtracted, we have multiplied, and that leaves division. Division is the weirdest one because you can end up with one of two scenarios. You can end up with something like this, 4 plus 2i over 3i. Or you could end up with something like this, where it's like 5 and then 2 plus, let's go with 3i. Okay? If you are dividing by imaginary number with an I on the bottom of the fraction, that is technically improper, and you're not allowed to leave it that way. And you're going to have one of two scenarios. You're going to end up with a single term on the bottom of the equation or two terms on the bottom of the equation. In both cases, you are going to have to multiply by something, but it's going to be a little different. If you have a single term on the bottom of the equation, you multiply by I over I to eliminate the imaginary number on the bottom, and that will do that. Because if you multiply 3i times I, you end up with 3i squared. And if we distribute this I, because we're multiplying by two terms, we end up with 4i plus 2i squared. And then from here, all you need to do is turn your I squareds into negative 1. If this is a negative 1, then this is going to be 4i minus 2, because 2 times negative 1 is negative 2. And 3 times negative 1 ends up being negative 3. And you can leave it like this in a lot of cases, but another way you can rewrite this is with the 4i minus 2, with the 4i being divided by negative 3, and the negative 2 being divided by negative 3 with a plus in between. And the reason that you would do this is because sometimes these things simplify. 4 divided by 3 doesn't really simplify, but most people would write the negative on the top of the fraction. And negative 2 divided by negative 3 is a positive 2 over 3. So there is a subtle benefit, but a lot of textbooks and answer choices leave it this way. But if it simplifies, they will split it up and simplify it individually. Okay? That's if there is one thing. Dividing by one thing, multiply by I over I. If there are two terms on the bottom, then you are still going to have to multiply, but you do not multiply by I over I. That would not eliminate the issue, which is you're not supposed to have an imaginary I on the bottom of the fraction. Notice how we didn't have that anymore. We had a negative 3. So if there are two terms, we still don't want an I on the bottom, but you do not multiply by I over I. You multiply by the bottom, but change the sign in the middle. It is called the conjugate, where you just take the exact thing here and just change the sign in the middle and multiply by that. You will have to FOIL the bottom out, and you may have to FOIL the top out, but in this case, we only have a 5 up here, so we're just going to distribute the 5. But if there were 2 terms, you'd have to FOIL the top and the bottom, which is quite annoying. 5 times 2 is 10. 5 times negative 3 is negative 15i over. If you want to FOIL this out, you can do it right here, or you can do it like somewhere up top or separately. I'm going to do it up top. 2 plus 3i times 2 minus 3i. Because this is like a separate problem. 2 times 2 is 4. 2 times 3 is negative 6i because it's a negative 3. 3 times 2 makes the positive 6i. 3 times negative 3 is negative 9i squared. And here's something cool. Because we multiplied by this conjugate, changing the sign in the middle terms will cancel out if you've done it correctly. 6i and negative 6i go away. 4 and negative 9i squared, well, negative 9i squared is going to turn into a positive 9 because that's negative 9 times negative 1. And if we combine 4 and positive 9, you get 13. Now, you could circle this answer because I know for a fact that 13 doesn't really go and simplify with either of these, but you are allowed, and some answer choices will, split these up into 2 different fractions because maybe both of them or one of them would simplify. But either version, this answer or this answer, I have seen written down. All right? So that's going to do it for this episode. Until next time, stay positive. I will see everybody later, and keep trudging forward. Bye.